Welcome back to you all. Today we are going to talk about ROMs. Okay. In the previous lectures we have gone through RAMs, various kind of RAM, SRAM, DRAM. Okay, and their read and write operations and a lot of other things also related to them. Today, as I have told you, we are going to talk about ROM. Okay. So what is ROM? ROM stands for read only memory. Okay, and the purpose of the ROM is to store permanent information, unlike RAM that was generally used in cache or just to that was containing the information that was required to execute any particular program. Okay, and the content of RAM was to be removed frequently. But in the case of ROM, whatever information I have stored in the ROM, that will remain as it is. Okay, just for your information, now we have got certain ROMs and which can be programmed, and the content of that ROMs can be changed, or we can rewrite those ROMs. Okay, so this is the conventional definition of ROM, that we can't change the content of ROM, but now we can change. Okay, so but in general we will say that whatever I have written in the ROM, that can't be changed. Okay, so this is the definition of ROM. A read-only memory is essentially a memory device in which permanent binary information is stored. Okay, so the binary information to be must be specified to the designer. Like let's say I want that ROM for any particular purpose, so if beforehand I have to specify those things to those details to the designer, and the designer will make the connections or appropriate connections to make my ROM, and once the connections have been made, that can't be changed any further. Okay, so in fact if I have switched off my device and again turning it on, then also the content will remain as it is. So this is your ROM. Okay, now we are going to see the block diagram of this ROM. So the first thing I have taken here is the decoder, k cross 2 raised power k decoder. So the purpose of this decoder is to decode the address decoder. It's actually, so at the input I have taken a generalized decoder. So let's say I have got k inputs, so the corresponding outputs will be 2 raised power k. These are k inputs, and the corresponding output is 2 raised power k. Okay, so these 2 raised power k are the different memory locations actually, or you can say address. Okay, so and these are address with the help of these k bits. Let's say if I'm talking about 3 cross 8 decoder, so 3 cross 8 decoder can address 8 different address. Okay, so and those 8 different address will be recognized by these 3 bits only. Okay, 3 bits are of the input. Similarly here, if I have taken k cross 2 raised power k decoder, so in this case total different memory locations I have got is 2 raised power k, and these 2 raised power k memory location will be addressed by these k bits. Those are available at the inputs. So this is the address decoder. Now in this address decoder, what I will do, I will store certain information, and those information will be stored permanently. Okay, now let's say if I want to have the access of these information, for that how I will have the access? For that I need to have the output lines. Okay, so these are the output lines. With the help of these output lines I will access these information. Okay, furthermore, let's say I have got n output lines. So this is your representing n output lines. In order to read these outputs, or you can say we'll take the outputs with the help of these OR gates. There is another purpose of these OR gates, I will just let you know. So as of now you can say that the block diagram of this memory contains 2 raised power k inputs and n output. Okay, because the input to the memory is that the output of the decoder only, and if I have got k inputs to the decoder, then the output of decoder was 2 raised power k. So now this 2 raised power k is the input of memory, and the output of the memory is n. Okay, so this is the block diagram of memory. Now let's see how we are storing the information in this ROM. So let's say this is the truth table specified to the designer, that I want a RAM with these specifications. Okay, like if I am giving 0 0 0 to my memory address decoder, or you can say MAR also, that then this MAR memory address register is known as MAR. Now this the content of MAR will be connected to the decoder, address decoder, and this will decode it as the first output of the decoder. Okay, and at the first output of decoder, when the first output of decoder is selected, then I want to store the information at that particular address is 101001. Okay, so now I have to configure this ROM so that I can have this kind of arrangement or this kind of output from my ROM. Okay, so just to focus, I have first selected my first row, that is having inputs at 000, or in other words, if I am giving 000 at my input of decoder, then what I need my output to be 101001. Okay, so how or what changes we have to make? Let's see here. For 000, I need I want to store this information 101001. In other words, you can say I need my U to be 1, and I need my W to be 1, I need my Z to be 1. Okay, what else? And I want my V, X and Y to be 0. So how will I achieve that? That's very simple. Simply you have to make a cross connection at the point where you want a 1, and you don't have to do anything for the outputs where you want a 0. Okay, so here we goes. See, I have make a cross because at U, W and Z, because at these particular points or outputs we were expecting 1, and at rest of the points we were expecting 0, or we wanted to store 0. That is why we have not made any connection at that. Similarly, let's say at 001, so at 001 I want this particular address to be stored in my memory, that is 010111. Okay, so if I have given 001 at the input of my address decoder, then which of the address line or word line will be selected? The second word line will be selected. Okay, so here I have selected this second word line, and now what I want to store at this particular address, I want to store 010111 at this particular address. So, or in other words, you can say I want my V, X, Y and Z to be 1, and rest of the inputs I want to be 0. So as I have told you, I will make a cross connection where I want as 1, and I will leave rest of the connections. So here we go. See, I have make a cross at V, X, Y and Z. Okay, similarly you can proceed further and you can complete rest of the design. Okay, like this. See, at third, or you can say that second 012, at second output I want my output to be 110001. That is why I have make these connections. Similarly you can proceed further and you can complete the design. Okay, so now once we have completed that, now we are heading toward the combinational circuit implementation using RAM. That was the explanation of ROM, and we have seen how we can store information in the ROM, or how it was programmed and how it will be accessed. Okay, now here we are going to see how we can realize certain combinational circuits using ROM. So for the sake of simplicity, I have taken the same table what I was having earlier. Here just the way we are understanding this table will change. Now this table is representing a combinational circuit whose inputs are, there are 3 inputs and 6 output. Okay, the 3 inputs are A, B, C, and the outputs are U, V, W, X, Y and Z. So if I am giving my input of this combination circuit as 000, then what I am expecting at output? I am expecting at output 101001. Okay, so let's see how will we realize this. So here we goes. Here I have got my ROM. So in the truth table, as you can see, the inputs are, there are 3 inputs only and there are 6 output. So in our ROM also, I have taken a ROM which was having 3 input to its decoder and 2 raised power 3, that is 8 input to its memory section and 6 output. Okay, so with the green table, where I have represented the minterms. Okay, and the minterms associated with particular outputs of the decoder, like with the 0th or the 0th output of the decoder, the minterm selected will be A bar, B bar, C bar. Okay, this is simply like a representation of the minterms inside the decoder. From the decoder, inside this decoder, we have those and gates only, and this will be the output if you are giving giving 0 0 0 at the inputs. So that is what I have written here, the minterms of the decoder. Now let's say the function, what we have to realize. Let's see the function what we have to realize. So this is the function. So just because of the limitation of space, I will take individual outputs. The first output is u, so let me have that u here. Okay, now what I have to observe for this u, I have to observe that which of the particular outputs I want. So rest, I don't have to do anything for rest of them. Okay, so just to highlight them, I have just black out rest of the outputs. So now as you can see, I want my output to be high for this u at 0 to 6 and 7 only. Okay, so that's very simple. Now which of them is representing 0? The first one, and then I have to have concern with second, 6th and 7. So I'm highlighting them. See here, now at these particular outputs only I have to make a connection or cross. Okay, and I won't make any connection for rest of them because I want 0 at that particular minterms. I don't want those minterms. Okay, so the minterms what I want, I will place a cross at them, and the minterms what I don't want, I will leave them as it is. Okay, similarly let's talk about v. So this is your v. Okay, now in this v, the minterms I want to be 1 are these. Okay, I have black out the zeros. So which are these minterms? These minterms are 1 2 5 and 6. Okay, so these are 1 2 5 and 6. So I am going to make a cross at 1 2 5 and 6. See, similarly you can proceed further, and now I have got the complete truth table here, excluding u and v. So for w, I need this particular combination, so, or I need this particular minterms, so I will make connections accordingly. Similarly you can proceed further and you can complete the design. Okay, so that was all about your ROM, and you have seen how the information was stored, or you can say in other words programming of the ROM. And here in this slide you have seen how we can realize different or various combination, not various actually, I have just told you a method how you can implement a combination circuit using ROM. Okay, now in certain questions you may not be given the truth table, you may be given some simplified expressions and you may be asked to implement that using ROM. Then how will you do? As we have did earlier, simply you have to change that particular expression, boolean expression, in its canonical form, and once you have converted it into canonical form, you can convert it in canonical form by using kmap also, and by using that method in which we were multiplying with the variables those are not present. Okay, there are these things, I believe that you all must be aware about these things. So once you have converted it into canonical form, then you have to find out the minterms, and just once you have got the minterms, then you will realize the function with the help of processor I have explained. Okay, now we are going to talk about PROMs. So what are these PROMs? So ROM was read-only memory, and this PROM is programmable read-only memory. So see, here we have got the word programmable. Now what does it mean? It means that we can program our ROM. Okay, so what do you mean by programming? Like in the previous method what I have shown to you, in that case or that thing was done by the designer itself. Okay, let's say I'm a customer and I want a specific ROM, and I have gone to the designer and I have explained my truth table that I want my ROM to be designed with these particular specifications. Then he will ask me to fill a particular form, and he will ask me particular details. I will give him particular details, and then he will configure my ROM with some specific machine and tools. Okay, so those kind of things are not advisable for a small production. Okay, if you want a bulk production, then only you can it is advisable to go for those kind of masking and other things. Okay, so what is the other way? The other way is to have or to use the programmable read only memories. In this case, what would happen, mean these things or these layouts are available in the market. You can go and you can purchase that, and once you have purchased, you can configure that in the lab also. Okay, so how will you configure that? We'll see that in the next slide. So here, as you can see, the ROM we have got is having all the connections. Like if I'm talking about U, so it will be receiving all the minterms, possible minterms. There is all the possible minterms like A bar, B bar, C bar, and everything will be available at U. So in other words, you can say that this is your U. Okay, and let's say for any specific or particular purpose, you want your U to be like this. Here in total we have got only 5 minterms. Okay, so we have got only 5 minterms, and we have to exclude certain minterms. How will you exclude those minterms? That's very easy. Simply what we'll do, we'll blow out those fuse. Okay, or what do I mean by fuse? I have not told you earlier this, all the connections what we have made here is with the help of fuse. Okay, and those fuse may be blown by blowing certain or specific voltages. That's all. Like if I will blow a specific not blow actually, if I will provide a certain voltage to those particular fuse I don't want, then that fuse will blow and the connection will be broken. Okay, so this technique we are using here just to get the desirable output. Okay, so let's talk about this updated U. In this case, I have got only 5 minterms. Okay, and rest I don't want rest of the minterms. So how will I do that? So first let's check about A bar, B bar, C bar. Do we need that in the updated U? No, we don't need that in the updated U. So I will remove that fuse. Okay, or I will blow that fuse. So now the connection is broken or open. Similarly, do we need A bar, B bar, C? A bar, B bar, C. Yes, we need that. So we won't blow that fuse. What next? Do we need A bar, B, C bar? A bar, B, C bar. Yes, we need that. That is why I won't blow that also. Now what next? A bar, B, C. So that A bar, B, C is not available here. So I will blow that fuse also. Okay. Now A, B bar, C bar. Yes, I need that. So I won't blow that. A, B bar, C. Yes, I need that too also. And A, B, C bar, I don't need that, so I will blow that fuse also. I need A, B, C, that is why I have written that. Similarly, you can blow rest of the fuse according to the designing or requirement of the design. So this is how we can program our ROM without much expenses or at in our lab also. Okay, so these kind of ROMs are known as programmable ROMs. So there is one more important thing, like this array or this decoder, it was having AND gates and those were fixed, so it will be considered as fixed AND array. And this complete mesh, it was containing programmable OR array. Okay, so that is a simple characterization. You can say that in the case of PROM, the AND array was fixed and OR array was programmable. Okay, now in the next lecture, not lecture actually, in the next video we are slide we are going to see EPROM. Okay, so what is this EPROM? It is nothing but erasable reprogrammable ROM. Okay, so Now, as of now, we have seen the programmable only. What was the advantage of that? We were able to program that ROM at in our lab also. Okay, and that was little comparatively uh, cheap, you can say, in comparison to the ROM. But now here we have got another thing, and in this case you can see that it is erasable and reprogrammable ROM. So we can reprogram our RAM. Once we have stored whatever information we have stored in this, can be reprogrammed or rewritten. So this is another advancement you can see in the ROM. Okay, so it is said that they may store information for a long time, but not for infinite, obviously, and some says that for 100 years. So they may be used in the place of ROM. Okay, so in this we use a special type of transistor known as floating gate MOSFET. Okay, and we store charges in that particular MOSFET only. Okay, so the special characteristic of this transistor is that it may be used as a normal transistor or as a disabled transistor that is always turned off. What does it mean? It means that if I don't want to store information at that particular transistor, then I will make it turn off, otherwise I will keep it turned on. Okay, so the important advantage of EPROM chip is that their content can be erased and reprogrammed. This is the something very important that distinguish it from other ROM. Okay, and see, for erasing we have to erase the charge trapped in the transistor of the memory cell. And how that can be done? For that can be done just by exposing that particular memory to UV lights. This is the reason of this transparent window. See, in this case, in this ROM we have got a transparent window now. So the purpose of this transparent window is to to facilitate the exposure of UV light. Okay, now here we have got another kind of ROM. This is your electrically erasable programmable ROM. Okay, so a significant disadvantage. Why we are talking about this? Because the disadvantage of EPROM. What is that? It is written here. A significant disadvantage of EPROM is that a chip must be physically removed from the circuit. You can't expose UV light to the circuit itself. No? You have to expose, or you have to remove that ROM from the circuit, and then you have to place it at a particular place, and then you can expose the UV light. Okay, so this is the one limitation of that. So an other ROM came into existence that can both programmed and erased electrically. Okay, so such chips are called EEPROM. Moreover, it is possible to erase the cell content selectively. That's another great advantage of this EEPROM. And the only disadvantage of EEPROM is that different voltages are needed for erasing, writing, and reading the stored data. Okay, so this is the only limitation of this EEPROM. Otherwise, it is very useful. Okay, so that's all for the day. In the next lecture, we'll talk about PLDs. Okay, thank you very much.